Imagine a point smaller than an atom suddenly expanding. This is the Big Bang, the birth of our universe. In an instant, all the matter and energy that would ever exist burst forth from this singularity. It was an event of unimaginable power and scale, a violent eruption of existence from nothingness. As the universe cooled, this energy began to coalesce into particles, then atoms, and eventually vast clouds of gas. These, in turn, collapsed under their own gravity, igniting the nuclear furnaces that would become the first stars. Galaxies formed, cosmic neighborhoods where stars lived and died, recycling their material in a celestial cycle of creation and destruction. Amidst these swirling galaxies, a particular one took shape: the Milky Way. And in a quiet arm of this galaxy, a certain star was born: our Sun. And in the midst of these cosmic fireworks, our own little corner of the universe began to take shape. Our solar system, a cosmic whirl of dust and gas, began to form around 4.6 billion years ago. Picture it, a vast swirling cloud of dust and gas spinning in the infinite darkness of space. The force of gravity, always seeking to pull matter together, began to work its magic on this cloud. Slowly, ever so slowly, the cloud began to collapse in on itself, the center growing denser and hotter. This spinning ball of fire and energy eventually became our Sun, the heart of our solar system. Around it, smaller clumps of dust and gas coalesced, forming the planets, including our home, Earth. In the beginning, Earth was a molten mass of rock, a world of fire and lava. But over time, the surface cooled and hardened, creating the first solid ground. As the young Earth cooled down, the stage was set for the next chapter in its history. Picture a world of fire and molten rock, steadily cooling under a blanket of steamy atmosphere. Imagine this fiery globe, our young Earth, transitioning from a planet ablaze to a world with a hardened crust. As the crust thickened and cooled, it formed a solid shell around the Earth, a shield against the inferno below. But even as the surface cooled, the heat within the Earth didn't stay trapped forever. It sought escape, causing the crust to crack and break into massive slabs or plates, introducing us to our first act of tectonic theater. Now let's add some water into the mix. As the Earth cooled, the steam in the atmosphere began to condense, and it rained, and it rained. Days turned into years, years into millennia, and the relentless rain pooled into the depressions on the Earth's surface. Over millions of years, these collections of water grew larger and deeper, eventually forming the first oceans. The story doesn't end there though. Remember those tectonic plates we talked about? They were still shifting and sliding, powered by the Earth's internal heat. Sometimes these plates would collide, with one being forced beneath the other, a process known as subduction. This would cause the trapped water to be released as steam, which would then rise and condense, contributing even more to the ever-growing oceans. The tectonic activity also played a crucial role in shaping the land. When the plates collided, they didn't just create subduction zones, but also mountain ranges and continents. The constant movement over millions of years gave us the familiar face of Earth we recognize today, with its sprawling oceans and diverse continents. And so, the stage was set. From a world of fire and molten rock, the Earth had transformed into a blue planet, cloaked in water and dotted with land. The oceans, once just pockets of water on a cooling planet, had grown into vast, deep bodies teeming with potential. And so, the Earth's stage was set, ready for the first actors to enter: life. From the depths of the primordial oceans, life began its incredible journey. The early Earth, a simmering crucible of elements, was ripe for the emergence of life, a phenomenon that continues to astound us with its complexity and resilience. The origin of life is a topic that has sparked many theories. One of the most widely accepted is the concept of the primordial soup. Picture a rich, hot, mineral-laden ocean bustling with the necessary ingredients for life. In this swirling broth, complex molecules began to form, driven by the energy of the sun, lightning, and Earth's own geothermal heat. These molecules, through countless interactions and unimaginable spans of time, eventually gave rise to the first nucleic acids, the building blocks of life as we know it. This was not life in the sense we understand it today, but it was a start that would set the stage for the evolution of the first cells. The first cells, simple and solitary, were unlike anything we'd recognize today. These early life forms, known as prokaryotes, lacked the complex internal structures of modern cells, yet they were perfectly suited for the harsh conditions of early Earth. Over time, these prokaryotes evolved, becoming more complex and giving rise to a new type of cell, the eukaryote, which forms the basis of all multicellular life. Fast forward a few 100 million years to the Cambrian period, a time of incredible biological innovation. Life, once confined to the microscopic, exploded into a myriad of forms. This period, appropriately named the Cambrian explosion, saw the emergence of most of the major groups of complex organisms that we see today. And so, life evolved from simple cells in the primordial soup to an incredible array of species, each more complex and fascinating than the last. From the tiniest bacteria to the largest dinosaurs, the Earth was teeming with life. From single cells to complex organisms, life was thriving, but a new kind of life was about to make its appearance. Enter the dinosaurs, a new breed of life that would dominate the Earth for millions of years. Picture the scene: gargantuan creatures lumbering across vast landscapes, their roars echoing through the air. Yes, we've now reached the Mesozoic era, a time when dinosaurs reigned supreme. These fascinating creatures first appeared during the Triassic period, around 230 million years ago. They were remarkably diverse, ranging from the towering Diplodocus to the diminutive Compsognathus. Dinosaurs evolved to fill every ecological niche, from fearsome predators like Tyrannosaurus rex to gentle herbivores like Triceratops. They thrived in every corner of the globe, from the dense jungles to the arid deserts, showcasing the remarkable adaptability of life. However, as we all know, the reign of the dinosaurs was not to last forever. Around 66 million years ago, their dominance came to a sudden and dramatic end. But why? What caused the demise of these incredible creatures that had thrived for over 160 million years? The most widely accepted theory is that of a catastrophic asteroid impact. This celestial body, estimated to be around 6 miles in diameter, is believed to have struck the Earth with a force 1 billion times more powerful than an atomic bomb. The resulting shockwaves, fires, and a nuclear winter effect, caused by dust and debris blocking out the sun, would have led to a mass extinction on a global scale. But it's not the only theory. Some scientists propose intense volcanic activity or drastic climate change as the potential culprits. Even multiple causes acting in concert are a possibility. Regardless of the cause, this extinction event marked the end of the dinosaurs' rule and the close of the Mesozoic era. With the dinosaurs gone, the stage was clear for a new kind of creature to take over. But who were these new rulers of the Earth, and how did they rise to power? To find out, join us as we journey forward into the age of mammals and the dawn of humanity. In the grand scheme of Earth's history, humans are newcomers, but what we lack in tenure, we make up for in impact. Now, let's dial back the clock a few million years. Picture a world dominated by creatures far removed from us, early hominids. These were our ancestors, rugged survivors who braved the elements and fought tooth and nail for every scrap of food. Over time, they evolved, developing traits that would lay the groundwork for our species, Homo sapiens. But our story doesn't end with the emergence of Homo sapiens. No, that's where it truly begins. Our ancestors were not content with merely surviving. They yearned to understand the world around them, to master it. This curiosity, this relentless pursuit of knowledge, led to the development of tools. From simple stone implements to the complex machinery we use today, each invention was a step towards shaping our world. Language, too, played a pivotal role in our ascent. It allowed us to communicate, to share ideas and knowledge, language gave rise to stories, and stories in turn gave rise to civilization. We began to build, to create, to innovate. We moved from caves to huts, from huts to houses, from houses to skyscrapers. We transformed the landscape, leaving an indelible mark on the earth. And yet, despite all our progress, we remain bound by the same primal instincts that drove our ancestors. We still yearn to understand, to explore, to create. It's these instincts that have propelled us from the Stone Age to the Space Age, and it's these instincts that will guide us into the future. From the Big Bang to the rise of humanity, the history of Earth is a saga of constant change and adaptation. Who knows what the next chapter holds? Remember, the history of Earth is not just a story of the past, but also a guide to our future. So don't forget to subscribe to this channel now for more fascinating insights into the world around us.